Okay, so hi everyone. We will be discussing our TCS NQ 2026 questions. Okay, that came today. Shift 1, there were two questions. These all are questions that students remember. These are memory based. Okay, these questions were recalled by students after TCS NQT 2026 exam. Okay, let me check everything's okay. So the actual wording may slightly differ. Now today's agenda is these discussing these two problems. The first problem is gym membership cost, and the second problem is transaction monitor. Okay, let's see what the question says. So this is what the question is: gym membership. We will be doing this particular thing in big of one operation and big of one time space complexity. Now, what does the question say? The gym offers membership plan based on number of months. Okay, a customer wants to enroll. Now, the cost is determined by table below. So, according to the membership plan, there is a table. Now, write a program that take a integer input where months. See, if the months is less than 0, we need to print invalid input. Okay, else we need to print the amount. Suppose the duration of the month is 1 month, then the cost will be 2000 rupees. If the duration is around 2 to 3 months, then the gym cost will be 5000 rupees. Similarly, for 4 to 6, it's 9000, and greater than 6000, it is 15,000. Greater than 6, it is 15,000. Okay. Now there are simple test cases given. Suppose there is 1 month, then you have to print the 2000. If there is 3 months, then you have to print 5000. If there are 5 months, you have to print 9000. 7 months, 15,000. 0 months, invalid input. That's it. Okay. A normal if check, right? Now, what is the intuition? What is the time complexity and space complexity? It's a pure conditional logic check, no loops, no data structure. A simple chain of if else covering each slab. Okay. Now, fixed number of comparisons regardless of any input. Okay, write a very simple problem to be solved here. Remember, these are memory based. Student recalled this particular question after the exam, so the words might differ a bit. Okay, now the input was given you, the read input, validate first. Okay, we will be reading the input first. Second, the validating the input, that if it is greater than 0 or not. If it is less than 0, you have to print invalid input. Now, next is the if check logics. You have to write if the month is equals to 1, or if the month is greater than 3, then what will be printed. These all things you have to see, that if the month is 1, you have to print 2000. Similarly, if it is less than 3 but greater than 1 or something like that, you have to print 5000. Similarly for 6, and similarly for else part. Okay, now the exact input format was cost colon amount with exact casing, no new line issues, match sample output exactly. Okay, now see, you have to check in which slab the user is writing into. Okay. Now suppose similarly we have just written the jab input the iostream file, use the using namespace std, we have written this heading lines. Next is the main function. We have declared the months variable, taken the months as our input. We have written the check for the first condition, that is the invalid input condition. If it is less than 0, we have to print invalid input. Next, we have generally divided this particular fees into slabs. So if it is falling into first slab, that is less than or equals to 1, then we are returning a cost of 2000. Very simple. If it is less than 3, see, if it is 2 also it is less than 3, but it is greater than 1, so it will be falling into our slab 2 only. Okay, that's why we have written if it is less than 3, then we have to print 5000. If it would be less than or equals to 1, then it would be fall into one slab 1. Else if it is great less than or equals to 0, then it would have fall into our this invalid input. Now similarly for less than 6, that is greater than 4 but less than 6, less than equals to 6, then we have to print a cost of 9000 rupees. Or else if it is greater than 6, then you have to print 15,000. Okay, this is what the code is for question 1. Okay, very simple. I have provided the Java solution also here. uh, Yeah, this is the Java based solution. We have just written the print statements and these four if and else condition. Okay, if and else chain. Now we have declared the months variable, taken the input, matched if it is less than equals to 0, then invalid input, equals to 1, or as the input was in integer, so if it is 0 then invalid input, if it is 1 then 2000, if it is less than 3 then 5000, if it is less than equals to if it is less than equals to 3 then 5000, if it is less than equals to 6 then it is 9000, or else we have to print 15,000. Okay, these are the slab 1, slab 2, slab 3 and slab 4. That's it. Now what is the time complexity? As we are not using any loop, as we are not using any data structure, so the time complexity will be big of 1, and the space complexity will be big O of 1. Okay, now coming to the next question. Now the next question is transaction monitoring system. Okay, this is question 2. Basically we will be using a data structure here and a for loop here. Now see, basically what we have to do here is we have to check first, is it a duplication or not, second, is it a fraud or not, or else is it valid or not. Okay, now see, what does exactly question say is you are building a transaction monitoring system. We have to monitor the transactions that are happening on our system. Now let's say there are n transactions. Okay, now each has four fields. First, sender, let's say the sender is A, the receiver, let's say the receiver is B, the timestamp when the transaction was made, and lastly the amount, that is amount. Okay, these four inputs will be there, these four fields will be there for a particular transaction, and there will be n transactions. Now there are two rules in order for each transaction: print only one output and terminate when a rule fires. Now, what are the rules? Duplicate transaction check. Now, if any transaction has same sender and same receiver, listen to it, same sender or same receiver, okay, as previous transaction A B 5000, well, 5000 A B 5000, same sender same receiver, same sender same receiver as previous, print error duplication transaction and then terminate it immediately. Okay, immediately. Now rule 2 is fraud detection rule. If the difference between the timestamp, suppose the for this the timestamp was 0th second, let's say it is 0. If the time difference, the difference between timestamp of any two consecutive transaction is greater than 60 seconds, then print fraud detected, then terminate directly. There might be a transaction made uh, below, or we can say under 60 seconds. That's why if the transaction time difference is being taken like more than 60 seconds, then you have to return fraud detection. Okay, let's say it is on 70th second, then we can see the difference is basically 70, so it is a fraud transaction. Now, if entire loop completes without triggering rule 1 or rule 2, then print all transactions are valid. Okay, all transactions are valid. Now, coming to the test cases, these are the three test cases. These test case one is for valid one. Now, what does it say? A and B transaction was made 10 transaction wait last one is okay, the second one third one is timestamp. So this is our timestamp, okay, and this is our amount. So sender to receiver, sender to receiver, so A send to B 100 rupees and the timestamp was 10. Okay, now next our sender and receiver is changing. Our sender is C and receiver is D, and the timestamp is 50. So the timestamp difference is 40, and the sender and receiver are totally different. So what we can say, it is completely valid. Coming to our next transaction, E and F. E and F, that means what? Sender and receiver both are changed, and the time difference, the timestamp here in the third transaction is 100. So the difference is 100 minus 50. So 50. So 50 is less than 60. So it is not a fraud detected. So we can say it's a valid transaction. Now moving to next, as our transaction completes, so what we can say, no duplicate transaction, no fraud transaction detected, so all the transaction were valid. Okay, coming to the second test case, now we can see here A is sending a particular amount to B at 10th second. Okay, C D, that means sender and receiver changed, timestamp is 50, checking with the previous, it's 40, valid. Moving to the next, A and B, we can see that previously this sender and receiver, that is A and B, was found. So what we can say, it's a duplicate transaction. Though the amount and the timestamp may be different, but as in the question given that the sender and receiver can't be same, so we can say that it's a duplicate transaction. And as we have found a duplicate transaction, we have to return error as duplicate transaction. Okay, moving to a fraud detected transaction question test case, we can see here the time gap, that is 50 and 200, the time stamp difference here is 150, which is greater than 60. So what we can say, it's a fraud detected transaction. Okay, coming to the intuition, what is the space and the time complexity for this particular solution? Now we will be using a hash set. Why hash set? Because we have to check whether the next transaction has uh, sender and receiver same as the previous transaction or not. That's why to track that particular thing, we will be using a hash set. Okay, now we will also be tracking the previous time. What was the previous time? Just previous transaction timestamp, because we have to check a fraud detected transaction also. So we have to track this previous time, so we will be declaring this as variable and we will be checking it for consecutive timestamp difference check. One, pass through all transaction. Now all of this particular checks pass, then we can say the transaction is valid. Okay, now how we will be approaching our intuition? First, we will be initializing a data structure. Now as we want to track sender and receiver both, so we will be declaring a set of pair string comma string, as we are storing the sender and receiver. So we will be declaring a set of a pair string comma string as a data type, and we will be writing a particular name for this particular variable, set variable, we can say scene. Okay, here we are declaring this set data structure as scene, which stores our sender and receiver. Now the duplicate check, that was rule 1. The duplicate check says that for each transaction, if sender and receiver is in set, okay, then we have to print error as duplicate found. That's why we declared set to track the previous sender and receiver. Coming to the check 2, that is fraud check. If my previous timestamp is equals to -1, that is if it is my first if it is my first transaction, then the previous timestamp will be -1. Now after first transaction, this previous time will be updated to a particular time, and moving forward with our timestamp, it will be updating with the time difference or the timestamp which are given in our transaction. Now the time difference should not be greater than 60. Now if it is greater than 60, then it will fall on rule 2, that is fraud detected. Now if it clears duplicate check, fraud check in all our transactions, then we can output rule 3 as for loop finishes out without returning any these two rules, then we can see all transactions are valid. So this is what the question was. We have simply declared a set with a data type pair string comma string and named it as scene. We have declared a variable previous time equals to -1. Why? To track. See, if my previous time is equals to -1, if my previous time is equals to -1, then it's my first transaction. For the first time transaction, we are not going to find the time difference. Okay, now first we will be taking the input of sender, that is, see, we have declared n, we have taken the n as input. Okay, now running the for loop from 0 to n, we will be declaring two strings, sender and receiver. There will be more two things, as each transaction has four fields, that is sender, receiver, timestamp and amount. So we will be taking the sender, receiver, timestamp and amount as our input, and first we will check if in any of my previous transaction was this sender or receiver present or not. So we will be checking scene count sender comma receiver. If it is found, then we will be printing error duplicate transaction, and we will be terminating our program as return 0. Now if this if check fails, that means we are not under our rule 1. We will be moving forward and inserting our this sender and receiver by creating a pair and then inserting this particular pair into our set and moving forward to check for rule 2. Now if my previous timestamp is not equals to -1, suppose if my previous timestamp is not my first, that means the transaction is not the first transaction, it is either second, third, fourth, or let's say nth transaction. If the previous time is not equals to -1 and the present timestamp, this present timestamp minus the previous timestamp that was stored in our variable is greater than 60, then we can say that it is falling, that our program, that all the transaction that is coming in our input falls under rule 2, which is fraud detected, and we have to print error as fraud detected and return 0. That means we have to terminate our program, or else, if my program doesn't go into this chip if check also, we have to uh, store our previous, that is current timestamp, and for the next iteration this current timestamp will be counted as my previous timestamp, and which will be stored in our previous time variable. Now this for loop will run, and if doesn't fall, that means if my program doesn't breaks, we can see these all transactions are valid and we will be returning 0. Okay. Now I have also added the Java based solution for this also. Now we have declared a set, we have declared a variable previous time, the initialized is as -1. We have declared these four variables also because each transaction have four fields. We have checked for, see here in this particular program, we have created the set as here data type as string, and for this string we are declaring or making a key with sender and receiver, and we are placing a dash here. Okay, and this will create our key. Let's say a plus a dash b, c dash b, like this the key will be created. So this key will be unique, and if this key will be found in further transaction, then we can see that there is a duplicate transaction and we will be falling into our rule 1, or else we will checking for rule 2. If rule 1 and rule 2 both doesn't get executed till my nth transaction, we will be printing all transactions are valid. Okay, and this is what will be our solution. Now for this, the time complexity will be big O of n. Now uh, this is the whole summary: gym membership cost and transaction monitoring. These were the two questions. First, we declare how did we solve. We used big of one. We only simple used if else chain for checking our slabs. If it is greater than if my months is greater than 1, it's greater than 3, 5, and we input our if and else check, and we just return the amount. For the second one, where we have to check it is a duplicate or a fraud transaction or not, we declared the hash set, and we also declared the previous time as our variable to track the previous time, and hash set for tracking the sender and the receiver. And we declare this data structure, and rest we check it is a duplicate or a fraud transaction or not, and we cleared the solution using a one pass solution. Okay, and a space complexity of big of 1, as we were using set. So that's all for today's video, and thank you everyone. So these were two questions that was asked in TCS NQT 2026. Thank you.